Welcome to AOML's Hurricane Model Viewer website. Here you will find tons of graphical products for both operational and experimental hurricane models. This video will serve as part one in a series highlighting the various products that can be viewed on the website. Let's begin by clicking on the Model Descriptions link. A new tab will appear showing descriptions of the models currently available on the website. We will start with these first four models here called operational models, which just means they're currently in use. GFS stands for Global Forecast System, which is a U.S. modeling system run by NOAA. Its forecasts are available 4 times a day at 0Z, 6Z, 12Z, and 18Z. Now you may be wondering, what does the Z stand for? Z indicates Zulu time, which is the military name for UTC, or Coordinated Universal Time. Its time is fixed at the prime meridian, or 0 degrees longitude. This means that Zulu time is 4 hours ahead of Eastern Daylight Time. So 0Z would be 8 p.m., while 12Z would be 8 a.m. Additionally, the GFS provides forecasts at 3-hour intervals out to 384 hours, or 16 days. Next is the ECMWF, which stands for the European Center for Medium Range Weather Forecasts. It is a global modeling system whose forecasts are available 4 times a day at 3-hour intervals. Its 0Z and 12Z forecasts are available out to 240 hours, or about 10 days, while its 6Z and 18Z forecasts are available out to 90 hours, or just over 3 days. These last two operational models, HWRF and HMON, are both U.S. modeling systems run by NOAA. HWRF stands for Hurricane Weather Research and Forecasting, while HMON stands for Hurricanes in a Multi-Scale Ocean-Coupled Non-Hydrostatic. Both models provide forecasts 4 times a day at 0Z, 6Z, 12Z, and 18Z, and at 3-hour intervals out to 126 hours, or just over 5 days. Now we will discuss the 2 experimental NOAA models that are being tested and are not currently in operation. HAFS stands for Hurricane Analysis and Forecasting System. There is a HAFS-A model and a HAFS-S model, with the main difference between them being the physics parameterizations included. The goal is to have these models eventually replace HMON and HWRF. Similarly, HAFS forecasts are available 4 times a day at 0Z, 6Z, 12Z, and 18Z, and at 3-hour intervals out to 126 hours, or just over 5 days. Now that we understand the basics of the various models available, let's go back to the main viewer page. On the left side here, there are various tabs that will help guide you through the website. Let's start with the Recent Events tab, which breaks down each tropical disturbance of interest and which models are covering it. You can click directly on the map image to view the model's graphical output for that particular storm. You can also click on the top right image to view the track guidance plot, or the bottom right image to view the intensity guidance plot. Clicking on this top bar here allows you to change the date and time of the model run. Now we will click on the Map tab. The Map tab shows all active tropical disturbances around the globe and their spaghetti track plots. You can scroll down on this page to see which colors are represented by each model. Next, we will click on the Summary tab, which shows each area of interest and named storm, both past and present. You can also click on this top middle bar to change the year that you're interested in looking at. Clicking on a storm's name will bring you to the last available model output for that storm, but you are able to change the date and time to whenever you'd like. Now we have a basic overview of the website's layout, so let's go directly into the viewer so that I can show you how the controls work. Go into the GFS model here. So on the top left view, part of the viewer is a drop-down menu where you can select which year you'd like to view data from. Next to that is a drop-down menu where you can select which model you want to look at. Beside that is where you can select the specific date and time for the model run, each arrow representing the previous date and time. The next drop-down menu allows you to select a specific active storm if you choose, but it is not required. Then you have your animation settings right here. The circular arrow on the left allows you to refresh the forecast times when a new model run becomes available. The left-facing triangle with a line brings you to the first frame of the model run, and the left-facing triangle next to it brings you to the previous frame. You can select the word play to begin the animation and select the word stop to end the animation, or you can double-click to animate and stop the graphics. The right-facing triangle brings you to the next frame, and the right-facing triangle with a line next to it brings you to the last frame of the model run. Clicking on the minus sign will decrease the animation speed, while clicking on the plus sign will increase the animation speed. Following the animation settings is where you can select which graphic type you want to look at. They are typically broken down into two categories: dynamic maps and thermo maps. I'll break down some of those products shortly. Next to that is another drop-down menu where you can change the basin that you would like to view. On the far right of the viewer settings, upward right-facing arrow is going to open the viewer in a separate tab. The square expands or compacts the viewer within the window, and the X closes out the viewer altogether. Now I will look specifically at some of the products available from the GFS model using Hurricane Lisa as an example. There are quite a few products here, so in the interest of time, I will only highlight a few. So mean sea level pressure is the default graphic that appears, if available, when selecting any model. This product is an easy way to determine where high and low pressure systems are located. The more blues and greens indicate lower pressure, while more reds and oranges indicate higher pressure. Next, we will look at the 10-meter winds. Again, this product highlights the locations of high and low pressure pressure systems and shows the direction and movement of the surface winds. And lastly, I will highlight the default wind shear product called Wind Shear 200 to 850 millibars. In case you're unfamiliar, millibars are a unit of measuring air pressure. The vertical coordinate for many weather maps is measured by pressure, as pressure decreases with height. This product represents deep layer wind shear, or the difference in wind speed and direction with height. Red areas indicate high levels of wind shear, yellow areas indicate moderate levels of wind shear, and green areas indicate low levels of wind shear. Generally, too much wind shear weakens a tropical cyclone's convection. Now we will take a look at some of the products available under the thermo maps. First, I will show the 700 to 400 millibar average relative humidity and wind. This graphic shows relative humidity in the mid-troposphere, which is a key predictor for hurricane intensification. The blue colors represent areas of high moisture, which is ideal for hurricane formation, while the brown colors indicate areas of low moisture or dry air, which is bad for hurricane formation. A few other graphics that I'd like to highlight are total precipitation and precipitation rate. This is total precipitation. Go back in time a little bit. So total precipitation shows exactly how much is expected to fall over a given area. The darker colors represent more precipitation. Precipitation rate is measured in millimeters per hour and indicates the rate at which precipitation is expected to fall. So again, the green, orange, and red colors represent higher precipitation rates. Lastly, I'm going to show the CAPE and helicity graphic. This indicates the amount of available fuel for a developing storm. CAPE stands for Convective Available Potential Energy and helps scientists get an idea of the severe weather threat for a landfalling hurricane. The darker these colors are, the more CAPE there is available in the atmosphere. Now stay tuned for part 2 of this series, in which I will break down even more of the available graphics on the AOML Hurricane Model Viewer website. Thanks for watching.